Already. Number 5, the electric field is constant over each face of the cube as shown. Does this box contain positive charge? No, I mean, that's fine. I want you to think about it, but do we need this? Okay.
Yeah.
Okay, so here we have 5. Here we have 10. Here we have 10. Here we have 15. Coming out of the back, we have 10. Coming out of the bottom, we have, going into the bottom. Going into the bottom, we have 20. Okay. So the question is, does the box contain positive charge, negative charge, or no charge? Explain. So, what is true about the electric fields going that way? See, if I take this, okay, why is it only selecting that? That's weird. Cursive. No, what is that? God, crap. Okay, forget it. I'll do this. Okay, so what is true about the electric field? So what's the sum of the electric field in the x direction? Or well, let me not say sum. How about what is? Let me erase this. What is the effect? There you go. Effect in the x direction. Right? It diminishes to the left, right? It reduced. So that, how would that be possible? Like if there was no charge in there, what would happen? Yeah, it would be 15 on this side, right? So how do you diminish the electric field over here? Yeah, there has to be something. There has to be something caused. Well, okay, let's just take it one at a time. Let's say this is going to decrease -5. And then what is the effect in the y? What is the effect in the z? So in the y, the effect is it's a decrease of -15. And then in the z, no effect. Right? It's like the same. So in the z-axis, it's like there's no net charge. Does that make sense? But in the x-axis, how do we create this? How do you create 10 and 15 like this? What do you put inside that box to do that? So let's see. If 15 is coming in, and if I put a plus in here, then that would make that more on this side? So I just need to put some negatives in here, yes? Does that make sense to everyone? So it's kind of like we know that we already know in the z direction it's equal, right? It's balanced. So there is some. If it's even on both sides, that means there must be like a positive charge in the z direction because it's coming out both sides. So if it's this way, in the x, we get that, so this is some sort of positive thing. In the x, if we have a negative, what is it going to do to this? Yeah, wouldn't this need to be positive to cancel? Well, let's see. If this is a positive inside like this, it's going to do this. Okay, so if you have this coming in at 15, oh, it's going to cancel, but then what about at this side and the other? Addition on the other side. Oh, thinking of like on the sides, not necessarily in the middle evenly, but on the sides. Oh, I get you. So we're drawing kind of like a cube with stuff on it. So in the Z, like there's a plus here, and then on the back side there's a plus. Right? So on this side be a plus to neutralize this, and then which would let that come through on the other side. And then in the up, so then are you saying this would be a plus here, and then the bottom would be positive to reduce that? Yeah.
What if they're talking about charge emanating from the box, not a field?
Oh, I get you. Maybe I'm thinking of this the wrong way. Maybe Kipman's saying what charges in this box cause these fields. It's not like there is this field outside. Does that kind of make sense? So if that's true, then this side would be negative, that side would be positive, this side's positive, the other side's positive, that side's positive, and this side's negative. Okay, that makes sense. And then if that's true, then if we look at the box, there's going to be more negative than positive, right? The question says, does the box contain, oh, so the field is constant over each of the faces. Does the box contain positive charge, negative charge, or no charge? So what do you put in the box to make this happen? So you would need negative here to pull this in. You would need positive here to throw this. So this negative is bigger than that positive. These two positives cancel out, and this negative is bigger than that positive. So it seems like we're saying net negative. Answer 0. Well, that's fine.
Just count what goes in and what comes out. Because I thought it's going
It's what in, no, it's the box itself. It's whatever's inside there. Here we go. So all of this sort of, okay. What we're all doing, and I have to admit, I'm sorry, I was doing this too. I'm trying to think of what universe can I put all these charges to make all this happen, right? So the net charge inside is 0?
What goes in is the same amount as what goes out.
What goes in is the same amount coming out? Coming out that's 10. This one going in, that's a net loss of 5 there, and this is a net loss of 15. How is it the same going in and coming out? Oh, I see, but if you add up all the directions of coming out, 10, 20, 35, going in 35.
So it doesn't matter, it's just like the direction?
Oh, sneaky. Okay, yeah, all right. So, all right, this is one of those questions where you got to kind of get in the mind of the person who's asking it. What are they trying to show you here? All they're trying to show you is if kind of like the E going in equals the E coming out, there is no net charge inside that thing.
So it doesn't matter the direction?
So this box just magically redirects electric field. Yes, the box bends electric fields. Okay, so let's just, this is not a vector problem. This is a scalar problem. So the idea is, I'm giving you a magic box that manipulates electric fields. How do you know if there's a charge inside or not? Because if there was a charge inside, this would not be true. Does that make sense? Yeah, so, I mean, it's a good thought question. But does everybody kind of get what the person who wrote it is doing? So they're saying, if there was any charge inside, then the net flux would be greater than 0. But since the net flux is 0, it's done. Okay, well that was fun.